Now let's consider an example in which we have a data set given in this tabular format. And in this data set you can see that we have a number of columns which represent a number of attributes, right? So in first column we have an ID which represents the total number of records in this data, and you can see that we have total 14 records in this data. In column number 2 you can see that we have age, and we have age. In some cases the age can be less than 30, and in some cases the age can be greater than 40, and in some cases we can also have age greater than 40. And you can also see that there is another case in which the age can be between 30 to 40, right? So there are kind of four possible categories in which we can have ages, which is less than 30, greater than 40, greater than 30, or between 30 to 40. And in third column we can see that we have the number of incomes. So in some cases we have high income, in some cases we have low income, and there are also some cases where we have medium income, right? And then in fourth column we have a category with the name of student, right? So this category is basically a binary category, so the possible outcome for student can be yes or no, right? So this column is basically telling us that whether the individual is a student or not. And in fifth column you can see that we have some credit ratings given, and credit rating can be fair, it can be excellent, and in last column you can see that we have a class which is represented by underscore computer. And again this is kind of a binary column which can only result in yes or no. So this is our data set which is actually representing some individuals, and those individuals, some are in a good state to buy a computer, and some of them are not in a good state to buy a computer, right? So now by having a close observation of this data set you can see that these are our input attributes, right? And this one is our output class, right? So we can train our algorithm, our naive Bayes classification algorithm, so that it can look for these attributes, and after analyzing these attributes it can tell us that whether an individual will be able to buy a computer or not, right? So the last column, we can take this column as the output column or the desired output column, and we can have a classification based on these attributes, and that classifier will result in a yes or no, right? So this is a fairly simple example, but it will help us to understand that how a naive Bayes classifier is performing classification. Now let C1 is the class which represents that the individual will buy a computer. On the other hand, C2 is a class which represents that the individual will not buy the computer, right? So we have two classes here, because if you look in the data set, if this is our output class, then you can see there are only two attributes, one is yes or no. So the total number of classes, the total number of output classes which we can make with this column are 2, because we can either have a person who is able to buy a computer, and on the other hand the person may not be able to buy the computer. So we are representing one class with C1 and the other class with C2 here. Now let's consider an unknown data sample which we want to classify, and here are the attributes of that unknown data sample. You know that the total number of attributes are age, income, student, and credit rating, and based on these four attributes we can basically classify the unknown sample to either class C1, which is here, and either to class C2, right? So now for this unknown sample, the attributes are age is less than is equals to 30. So the individual can be 30 years old, or maybe he is less than 30 years old, and his income is medium, and he is also a student, and his credit rating is fair. So these are the values of these attributes which are known to us. So we now know that the individual is a student with a medium income, having an age less than or equals to 30, and his credit rating is fair. Now once we have these attributes and their values, we can now calculate the prior probability of each class. And now you know the formulas through which we can calculate prior probabilities, which we have studied in previous slides. And you know that the probability that the individual will buy a computer, which is basically the probability of class C1, and probability of class C1 that it will be is equals to yes will be 9 by 14, right? So this 14 is basically the total number of samples, the total number of rows which we have here, right? So you can say that these are the total number of records in our data set. And now out of these 14 records, there are total 9 records which are resulting in yes, right? So if you count this here, you will see that the probability that the individual will buy a computer is having to yes will come to be 9 by 14. And on the other hand, the output class with a no, which represents that the probability that the buying of the computer will result in no, is total 5 in the data set, right? And again the total number of samples are 14, so here we are dividing it with 5 by 14. So this probability will come out to be 0.643, and this probability will come out to be 0.357. So we have these two prior probabilities here on the basis of our input data set, on the basis of knowledge we have here. Now the next thing is that we need to calculate or compute the probability of unknown sample with a given class Ci, right? So now we need to compute the following conditional probabilities, and these conditional probabilities are on the basis of x given Ci, right? Now we are calculating the first probability, where we have age less than 30, given that by underscore computer will be yes. So all these probabilities, if you look into the data set, you will see that these comes out to be 2 by 9, and the probabilities for having age less than 30 and by computer is equals to no are 3 by 5. Similarly, on the basis of incomes, we have probabilities 4 by 9 and 2 by 5, and the probabilities on the basis of students, we have 6 by 9, 1 by 5, and the probabilities on the basis of credit rating, given that he will buy a computer or not, are 6 by 9 and 2 by 5 respectively. So all these fraction numbers are coming from all these conditional probabilities, which we are calculating by following the same formulas which we have studied in the previous slides. So now once we have the prior probabilities and the conditional probabilities calculated, then by using these calculated probabilities, we can obtain that the total probability of the unknown sample x, given that he will buy the computer, is equals to yes, will comes out to be 0.044 if you multiply all these which you have obtained in previous slide. Similarly, by following the same fashion, we can also calculate the probability of this unknown sample for the class that it will not buy a computer, you can multiply all those probabilities which we have calculated from here, and you will see that it will come out to be 0.019. Okay, so now hence the naive Bayes classifier predicts that the student will buy the computer, right? So the output class for this specific attribute or a specific unknown sample having these attributes, our classifier is predicting that the student will buy the computer. Why? Because if you multiply the two probabilities, one is the total probabilities which we have obtained from the conditional probabilities with the prior probability, you will see that it will comes out to be 0.028, and this is the probability which is for the class by computer yes. And if you see, the other probability will be 0.007, which is for the class by computer no. Now you see that the highest probability here is 0.028 as compared to 0.007, and by theory we know that we assign the unknown sample to a probability which is the highest, and in this specific case 0.028 is the highest probability value. So our classification algorithm will assign this unknown sample x with these specific attributes to this specific output class.